Solving equations with variables on both sides is the same as solving any other type of equation with variables. You want to get your variable on one side, you want to get everything else on the other, isolate the variable, get it by itself by doing your opposite operations. Again, you can only add and subtract with like terms, same variables or no variables. And yeah, I mean, you kind of go from there. And the thing is that the way that you do it might be different from the way that I'm doing it. I'm going to give you a place to start just so that we're all kind of, somewhere together at least. But we should end up with the same answer regardless of which term that we begin with. Okay. I like to start by getting your variables on one side and then getting your constants on the other. But it is totally up to you. So there is that disclaimer before we get started. Yes, you can start it at a different position, and yes, you can still get the answer right. Okay, so don't be scared of it. There's a couple word problems on here at the bottom, but again, anything you do to one side, you got to do the other. That stuff still applies, and Emery's going to help us out with a couple of them. So here we go. All right, number 3, it says 7c minus 7 equals 4c plus 17. And again, line down your equal sign. Again, with our variables, you can do either one, right? You could either subtract 4c or subtract 7c. My first move would be to subtract 4c from both sides. Subtract 4c. And again, you can always subtract something with a c from something else with a c. So that's 3c minus 7 equals 17, right? Those cancel out. Now, next move, this is a two-step equation that you got left, right? Get your c's on one side, so let's get our constant on the other. Get the opposite of subtract 7. You always take the operation in front of it with it is to add 7, and 3c equals 24. This is a one-step division equation from now. Divide by 3, and you will get your answer. Okay, number 4. Now, in this case, you know that I said we want to get our variables on one side first. The thing about this is our constant is already over here by itself. 15 is already over there. So it only makes sense to get your variables to the other side. So the opposite of minus 6t should be to add 6t. And again, you got to remember both your adding, subtracting quantities and your multiplying, dividing quantities. In this situation, we have 15 over here. Negative 11 plus 6. Different signs, subtract, keep the larger. You got more negatives. It's negative 5t equals 15. That's a one-step equation. Divide by negative 5. Both sides, different signs. Again, you will get your answer for t. Okay, number 5 right here. 20s plus 4 equals 13s minus 10. And again, I would start, since I have 4 terms, I can start any of those 4 positions. Personal preference, I would subtract 13s from both sides. As long as you're doing the opposite. And again, you only do the opposite when you go across your equal sign, right? But that is 7s plus 4 equals, now not just 10, is a negative 10. Now that's a two-step equation. Subtract 4 on both sides, divide by 7 on both sides, and you will get your answer for S. All right, now here's a fun one. Number 6. We have negative 2h minus 16 equals, and then we got a distributed property here, right? 3 times everything that's inside the parentheses. So that's 3h. And again, minus 3 times 2, which is a minus 6, not just a minus 2. Okay, keep that in mind when you're doing distributed property. Multiply what's outside by each term on the inside. So I got negative 2h minus 16. I'll give you a couple extra steps here. I would actually add 2h to both sides. It's because I like to keep it a positive coefficient when it's possible. It's not always possible, but in this case it is. Equals 5h minus 6. Now, again, from this position, I got my variables on one side, so I'm going to get my constants on the other. The opposite of minus 6, add 6, add 6. That's a negative 10 equals 5h. And then divide negative 10 by 5. That'll give you a value for h. All right, thanks, Emery. See you later. Okay. Now, couple more. Again, I'm just going to leave this one here for you. So you guys kind of got this one. Solve for j. Get it on one side. Constant on the other. But 25 times that number minus 6 equals 14 times that same number plus 7. All right, number 8. Same idea here. And my first move would be to subtract 11w from both sides. And again, you can only subtract, add and subtract like terms. But whatever the case, make sure you always take the operation in front of it with it, okay? So those are two-step equation. I'll leave it there for you. Solve for w. Okay, number 9 here, 8 minus p equals negative 12 minus 3p. Again, a lot of ways to go. I would add 3p to negative p. Now, the thing is here that, again, that's an invisible 1 there, right? So that's a negative 1 plus 3, which is 8 plus 2p now equals negative 12, okay? So that's how I would attack that one. Again, there's a lot of ways to do it. And then solve for p, subtract 8, divide by 2, and you get your answer for p. All right, over here, number 10, 9k minus 26 equals 6k minus 8. I would subtract 6k and then add 26 to both sides, and then divide by 3. Okay, another distributive property here, which I'm going to give this one a little bit more on your end here, but yeah, make sure that you multiply what's outside by each term on the inside. Okay, now 4 times 7 is 28 minus 4 times d, which is a negative 4d, equals 5d minus 17. So it's the exact same problem. Nothing has changed. We just distributed out that 4 to both of those terms inside your parentheses. And you solve for d. You can go either way, right? I would add 4d to both sides and then add 17 to both sides and then divide by 9. But your world. Okay, now this one doesn't get much simpler than number 12. I already have, like we talked about, my constants over here. So I would get rid of that 2y on both sides. And weird enough, when you do that, a lot of people get confused, even though this is one of your easier ones. You get a negative 1y or negative y. Now, when I solve for y doesn't equal 7. The opposite of y equals 7. So, again, the other thing you could do is divide by negative 1 and then give your answer. Okay, so there's all the parts up top. I want to look at these two problems here, all right? On the bottom, we have two word problems, and just like we did earlier when we translated our 1- and 2-step equations from words into equations, we're doing the same idea. Only difference is that now we're going to have variables on both sides. So when we look at this, you're still breaking it down, you're still finding all your pieces to the puzzle, and all the rules that we just talked about is being your separator. That's still true. Okay, so let's look at number 21. Twice the number is 60 more than 5 times the number. Okay, so all the stuff that comes before the word is going to go on one side of my equation, and all the stuff that comes after the word is going to go on the other side. So when I do that, I already know, and I'm breaking this down, twice the number. That's 2 times the number. I don't know what the number is. That's my variable. Is equals 60 more than 5 times the number. Now, it's going to be the same number here and here. So you're going to use the same variable. okay? So 60 more than, that's plus 5 times the number, 5n, and then you solve for n. So there's your setup though, and again, it's just all predicated, it all begins with your equal sign, and then you just break down each side. Whatever comes before goes on one side, whatever comes after goes on the other side. Okay, now for number 22, 4 times a number is equals 21 more than the number. All right, so again, if I'm looking at this, 4 times the number, sure, 4n is equals 21 more than the number. More than, we're going to add to that number, and then you solve for n. So